Yes, sir. Yes, sir. You are audible, sir.
Good evening, everyone.
Yeah, good evening, sir.
Okay. So,
Uh, Sir, before we proceed for the meeting, I have one doubt in the lecture video. So, sir, may I ask in that time, sir?
yeah, just give me 1 minute. Just give me 1 minute.
Okay, sure, sir, sure, sir.
Yeah. Yes, you were saying something. Hello.
Yes, sir, yes, sir. I was saying that miss, I have one doubt in the lecture video. Actually, I am not able to execute the code. So, sir, if you can help me to resolve that.
So I will share the collab file here, and we will explain the code. If you have some doubt regarding that, you can ask at that time. Okay.
Means, sir, it is a very specific question. Related to the lecture video only.
Okay,
So, in the interest of the larger audience, I thought I should not disturb to others also. So that's why
what's your doubt?
Sir, actually, in the lecture video 3.4, means video time was 8 minutes. I was trying to just copy the code and execute it, but it was not executing, showing some kind of error. So, if you allow me, then I can share my screen also, collab file also.
Okay, you can do one thing. I'm gonna share the same collaborate that I use in the lecture, and you just check what mistake you have done there. I think you are not allowed here to share your code, or you can share paste your code in the chat box so others can see what is the possible mistake there.
Okay, sure, sure. I'll definitely paste it. Actually, sir, I tried to resolve it through the Discourse also. But I miss problem was
when did you post on the Discourse?
Sir, yesterday I posted, and Swarnim sir tried to resolve it, but it was not resolved.
Okay, I'll check all the doubts there on the Discourse. I haven't gone through all those, and I'll try to answer there. Okay.
Yes, sir. I'll just post. So give me 1 minute. I'll post my code.
So, how many of you have attended the events? IITM?
I have attended, sir.
So you came there. Nice.
Yes, sir.
So how was it?
Just copy all the code.
Okay, so let us start the session. So this session, it's for MLT week 4. And this session is about the not the open session, this activity or practice question session where we will solve the activity and practice questions. And before solving those questions, we will go through the collab that sir has used in the lecture, so that our basic idea behind that week will be clear. Okay, so let me share my screen first. Okay, so this was your program. Okay, I pasted it. I will try to see what is the possible mistake here, and then I will come to you. Okay.
Sure, sir. Sure, sir.
Okay, so first let me share my screen. My screen visible?
Yes, sir.
Yes, sir, it is visible, sir.
So am I audible clearly? I think you are not audible to me.
Sir, you are audible, sir.
Okay. I think it's problem from my side. Okay, let's start. So in week 4, we have covered the classification problem. Before that, in week 1, 2, and 3, you have seen the regression problem. And you know the difference between classification and regression. The main difference is in the labels. In the regression problem, there is a real number associated with each and every example. But in the case of classification, each and every example is associated with some category or some classes, right? So these are the difference between regression and classification problem. And here from week 4 onwards, we will see some classification models and some of the regression model as well. Okay, so this is the starting of classification problem. And in week 4, we will see the linear classifications. Okay, so what I mean by linear, linear means the decision boundary. Decision boundary means that that differentiate between two different classes or more than two classes, or you can say the hyperplane or hypersurface that divides your input space into different classes, and each space belongs to some different classes. Okay, so that decision boundary should will be a linear function of the inputs features. Okay, so if that linear, if it is linear in features, then we call it a linear functions, linear classifications. Okay. Okay, you can it's fine. You can code. You can paste it again. Okay, so let's start. Here we have covered two models. One is using Classifier. Second using Perceptron. Okay, so idea behind this is very simple. First, we first we will see for the binary classification problem, and then we'll extend our notion to the multi-class classification problem. Okay, so in this collab, first here it is importing of libraries. And this thing you have already seen, polynomial transformation, how to do the polynomial transformation. So this part I'm skipping. You can see, if you want, you haven't seen, you can see in the week 3 sessions. Okay, so next thing that comes is the label encoding. And this is very crucial stage in the case of least square classification problem. So what do you mean by label encoding?
So changing the text to the numeric values, like ordered numbers?
No, that is not label encoding. So here labels, let's say you have two labels, two classes, 0 and 1. Okay, so let's say your problem is binary classification problem, and so it means that you have only two outputs, 0 and 1. And this is single level output problem. It means each and every example is associated with one label. Okay, so one example belongs to class 0, other belongs to class 1, something like that. Not more than one class, one label. So that problem is called single level classification problem. Okay, so in this case, class 0 will be represented 1 and 0, and class 1 will be represented as 0, 1. Let's say there are k classes, then class 0 will be represented will be vector 1, 0, 0, and class 2 will be represented as 0, 0, 1. So it means that if there are k classes, this will be your k vector of length k, and the row corresponding to that class will be 1 and other entries will be 0. So if it is class 1, then the entries corresponding to the row number, column 1 will be 1, other entries will be 0. So that's how you do the label encoding. So remember, if you are doing the least square classification problem, you have to first encode your label using label encodings. Okay, otherwise your problem will not be solved. So why we are doing this, we will cover in the theory part. First, we will see the code how to do the label encoding. Okay, so for doing label encoding, we have defined a class label transformation transformer, where object is just the number of classes. Okay, so here let's see one example, so the code will be easy to understand. Let's say your very toy example I will be using here. So let's say this is your label vector 1, 0, 2, 1. So you have 4 examples, and first example belongs to class 1, second example belongs to class 0, third example belongs to class 2, and the fourth example belongs to class 1. So this is your label vector, and now you have to do label encoding on this vector. So how your what will be the size of label encoding, the encoded matrix?
3.
Size of matrix.
3 by 4.
3 by 3. 3 by
4 by 3.
Why 4 by 3?
The 4 features, sorry, 4 labels. Each of it will have 3.
No. You have 4 examples and 3 classes.
3
Right?
classes.
0,
So
1, and 2, 3 classes and 4 examples. So every row will corresponding to 1 example, and there you have 4 examples. So there will be 4 rows. And how many classes are there? 3 classes.
3
so
classes.
you will have 3 classes. Sorry,
4
3
by 3.
columns. Right. So that's how your encoding matrix will look like. And the very first row will be what? It will be 0, 1, 0, right? The second last row will be what? 0, 0, 1. Clear? So that's how your encoding matrix will look like. So for that, let me define. Okay, so first I have to run this row. I haven't. So I'm just importing this libraries. Okay, so how you define an identity matrix in number? How do you define identity matrix?
np.i.
Right, and what will be the size of this? Let me define this code. So how your E will look like? So E will be something like that, right? This thing. So in remember, in the encoded matrix, the first row will be the same as the second row of the identity. I mean the first row. This is the 0th row. This is the first row. This is second. This is first. This is second. This is fourth. Here we have 4 examples. So we have an identity matrix of 4 by 4, right? And in the encoded matrix, the very first example will have the rows similar to the second row, or say first row of identity matrix, right? And the second example, because it is
this should be 3, right?
same.
Sorry, this should be 3, right? NPI of 3. There are only 3 classes.
Okay, because we have 4 examples, that's why we are doing this. You will that will be clear to you in the second step. So look at the second example. Second example belongs to class 0. Okay, so that will be the row 0 of the identity matrix. Okay, the third example belongs to class 2. Okay, so that will be the row second.
Should be class 3, right?
Class 3.
Yeah, 3 class. So the total number of it is a 3 by 3 matrix.
Yeah. Okay, so thus fourth will be what? Fourth example belongs to class 1. So this the row will be the first row of the identity matrix. Okay, so your Y encoded will be look like. How your Y encoded will look like? It is just the identity matrix, but with the suppling of rows, right? How you will supply rows according to Y. So now look at the Y encoded. Like this now. Okay, so these are nothing but the rows from the identity matrix, and something is done according to Y. So the first example belongs to class 1. Here it is class 1. This is class 0. This is class 2, and this is class 1. So this is the idea behind the class encoding.
Sir, how is it decided 0 or 1 will be assigned to which number? For example, in this, the first number in the array is 1. So the first row after applying the particular that particular encoder is
No, you
0,
see the
1, 0.
pattern. You see the pattern here. So the first example belongs to class 1, right?
Okay.
So this is the entry first row of the identity matrix.
Okay.
Here. So this is the first row of the identity matrix. For the second example, this is from class 0, right? So this is the 0th row of the identity matrix. This is second. Third example belongs to class 2, and this is the second row. So 2 belongs to 2, 1 belongs to 1, 0 belongs to 0th row, and 1 belongs to first row of the identity matrix. So what I'm doing is I'm taking identity matrix, but shuffling of the rows.
So sir, what
How
if
I'm doing
the
shuffling?
array consists of numbers like 4, 5, 6, 7? So then what will we, how will
Sorry?
we interpret? If the array Y array, which contains 1, 0, 2, 1 as numbers, in place of these.
So these are just classes encoding. You can encode them again, encode them 0, 1, 2, 3. If you are not encoding them again, you can just simply say like in that case you can say it is just identity matrix and your shuffling will be by -1. So what will be by -1? Each and every entry will be -1. So if the classes are 1, 2, 3, 4, something like that, so by -1 will have 0, 1, 2, something like this classes. So again it will start from 0. Right? Clear?
This is not clear. -1.
No, in that case, I'm talking if the classes are your classes are 1, 2, 3, 4, something like that. Let's say this one. Your classes 1, 2, or
Sir,
3.
my question was like that the label consists of different classes. Consider the particular label consists of 4 classes. 4 classes, as in there are numbers. There are direct numbers which are like 3, 7, 9, or 8, whatever may be.
3, 7, 9, 9, 8. You have only 4 classes, or
Yes,
these
sir.
classes, or some 3 to 7 all such classes.
Yes, sir. My direct question was like these numbers can be replaced by any other numbers. So then how will we encode them using the identity matrix as you mentioned?
They will be sorted, and like their sorting order will determine the rows.
No, actually, I didn't get your doubt. So
Can you like create a Y2 with NP array 3, 7, 9, 10, something like that? Another example.
I think the question is like this, right? So if you have 3, 7, 8, 9, 10, then you are probably having 10 or 12 classes.
Yeah. So my doubt is if you are saying your classes are 3, 7, 9, 10 something, so your classes are only these 4 classes, or all the classes from 3 to 11?
No, sir, only 3, 4, 7, 9. Only those 4.
You can what you can do, or if I generalize your question, you can say you have classes something like that, yes, no, something like that, or say some different names of fruits, apple, guava, whatever 5 fruits you have. So how you will encode them, right? So one way to do that, you first again recode them. Recode means you can say apple is 1, guava is 2, or whatever the fruit is. Okay, it's 0, 1. So you can encode them because these are classes. It represents class. So you can again encode them. If you have classes like 3, 9, 11, 12, so you can again encode them. You can say 3 represents 0, or class 4
sir,
represents something like that. Okay, just encode them again. They are just classes. Okay, you are renaming them. You can say you are renaming them.
Yes. So
So usually if you have 4 classes, we generally take it as 0 to 3. So whatever be the class, we start from 0 and k minus 1. Is it so?
Yeah, it's yes, same.
Okay.
Okay, so this is the idea behind how to encode the matrix, and decoding is just the opposite of encoding. So if you have been given encoded matrix, you have to return the decoded matrix. So from here you have to return by. So how you will do? You just check the row. So here it is 1, so you can say it is class 1. If it is okay, so this is identity matrix by encoded. So from here you can see this belongs to class 1, this belongs to class 0, this belongs to class 2, this belongs to class 1. So you can see where your 1 is occurring, right? Here is occurring at the first place, here is occurring at the 0th place, here it is occurring at second place, and this occurring at the first place. So according to that, you can decode that.
So sir, this can be said that for the class 1, the encoded result which we got 1 at the second place. So whenever 1 reads, it will be like 0 1 0 every time. That's right, no?
Yeah, that's correct. Okay, so this is the idea behind this code. So
Sir, the argmax, can you please explain that argmax?
Yeah, I'm just explaining both these codes. So encoding, here in encoding we are defining n classes. So here n classes is what? N classes are the number of classes. If it's k, then it will take k, and if the classes are not defined, then you will take the here class indices. Here it is the argument in the method called encode. Class indices are the your label vector. Okay, so you will check the maximum entry in the class indices and +1. So remember, in our case we have 1 0 2 1, so maximum entry is 2 and number of classes are 3. Similarly, if you have 0 to 4, so number of classes will be 5. So your number of classes will be, so maximum entry in the label vector +1, so that's gonna be your number of classes. And if it is already defined, then it will be taken already. Okay, and here it is returning encoder class indices. So what is encoder here? So here encoder is defined as self dot underscore underscore encoder, and here you can say encoder is the if it is number of classes, if none, if k is none, and s identity matrix of size k, and none if k is none. That is, if there is no classes defined, predefined, then it will be taken as none. Okay, it is just to avoid the error if there is no classes defined. Okay, so encoder will be your identity matrix of size k. Then encoder of class, and this is the same thing we have done, right? We have done E of y. So the same thing it is returning. So it will return you the encoded matrix. Okay. And what will decode to? Again, it is taking the encoded matrix. Now it will return the label vector. So how you will find the np.rms is just check at which entry the maximum occurs. Okay, not the maximum number. It's check at which entry. Okay, and so axis 1 will show the it will check in the rows. So axis equal to 1 setting, it will say that you will check in every row at which column the maximum occurs, right? So here, if this is your encoded matrix, it will check in every row. So first it will check in the first row. So at which entry, which and number of column, which column the maximum occurs. So maximum occurs at column 1, right? So it will return 1. And then again it will check for the second row, then third row and fourth row. So in that way you can return your label vector. So that's how your decoding is working.
Here 1 hot is the encoded value.
1.
Here the argmax argument is 1 hot and axis. So 1 hot is the encoded matrix.
Yeah, 1 coded is the encoded matrix that is taken as the argument in the function definition. Okay.
And returns an array of like maximum
array, single one-dimensional array.
Okay.
So this axis 1 means the column. It's going to check the column, right?
Axis equal to 1 means check argument according to columns, but in the row it will check in the row. So it will check in the very first row the column at which the maximum occurs.
So instead of that, where you put this array 0, can you put 3 and just run it again and just explain how just
this
put
one?
3? Yeah, 3.
Then you have to encode in that way. So 1 will be what? 1 will be 0. 1 0 0, right?
Then E will be 4 by 4, right?
No,
Yes.
E will be 3 by 3 because you have only 3 classes.
So here you have to reduce by 1, right?
Reduce by 1.
Okay.
Because your 1 will be encoded as 1 0 0.
Okay. So if we put 0, this matrix what we are giving with the identity. So it is just broadcasting this Y array into the identity matrix.
Yes, exactly.
Okay.
So that's how this code works. Next is your
Sir, one more thing. This is all implemented as class, right? So should we also follow this class, or because this is finding little bit complicated?
no. If you are not comfortable with this concept, you can just simply again define different functions.
Separately we can define, and that is okay,
Separately
right?
you define. Yeah, that is okay. You should know the actual concept behind it, how these methods are defined. If you're not familiar with the class concepts, okay.
Okay.
But it's better to know how these are working.
Yeah, if we understand the concept and if we can redefine with our own, without class, it is okay, right?
Yeah, it's okay. It's completely.
Okay. Okay.
So this argmax, can you explain once more what does that argmax do? It takes the maximum or
argmax. So argmax checks the entry at which maximum value occur.
Okay.
One more doubt, sir. Like if we have just two classes, do we need two features after encoding, or one will be
No,
sufficient?
classes, number of classes, and number of features are two different things. You can have more than two features, but here encoding, we are encoding the labels, not features.
Oh, sorry. I'm asking, like, if we have two classes, 0 and 1, suppose, and can we just use one column in encoding rather than using two columns? Because one column will also give the
Then
same.
how you will encode them? How you will encode them?
So one will represent 0 will represent the first class, and 1 will represent the.
So that is your label vector. This is your label vector. But if you have to encode them, then that will be your matrix. Okay.
You can do that, but then the code
optimization, right? We can do the optimization in that case. Like we can use just one column.
Okay, so in the case of this classification method, the discriminant analysis, not analysis, discriminant classifier. For if you have two classes, you will define two discriminant functions. If you have k classes, you define k discriminant functions. So for defining different number of discriminant functions, you just encode them. That is the reason behind you encode your label vector. Okay. So there is possible one mistake in the lectures. If you have noticed the loss function that Sir has defined. Have you noticed that there was one mistake in that model? So model is okay, fine. Now loss function is defined in that way, right? So there is one mistake in this. Have you gone through the lectures?
I have not.
So notice here that the loss function is coming out to be a matrix, right? This is gonna be a matrix. Is loss function is a matrix or a scalar quantity?
Scalar quantity.
Right. So what's the mistake here?
Coming out to be a matrix.
Yeah, so it's a k by k matrix. It should not be the case. Loss function is always a scalar quantity that gives you the loss, the error in the model. So here actually it is not the matrix, it should be the trace of a matrix. Okay, so this is the possible mistake in the week full lecture. It is not rectified yet. We will try. I'm not sure whether we can do in this run or not, but we will possibly look into this whether we can correct it or not. So remember, loss function here it is not a matrix. Here it is gonna be the trace of this matrix. Okay, you can verify it as well. You just take the simple example, three classes, and you can just take very simple example. This is your features. You can start with 3 features or 2 features, and you can see the trace will give you the. You can verify that trace will give you the loss function, not the matrix. Matrix doesn't make any sense in the case of loss.
Trace of which one, sir?
Huh?
Trace of which matrix?
Trace of this matrix. The same here it is defined. This matrix. Trace of this matrix.
Okay.
Here we have used the regularization as well. If we are not regularizing, then it's just the this matrix. Okay. So what is the model in the case of discrete classification? So what's happened in the discrete classification? Let's say you have k classes, so you define k discriminant functions. So discriminant functions are nothing but just the linear combinations of the features. Okay, so you take the linear combination of features. If you have k classes, such k discriminant function you define and check for which value now you have to predict. So every time a new examples comes in, you just check the value of the discriminant function for which it is maximum. You will define into that class. Let's say if it is maximum for the by k, then that example belongs to the class k. If it is maximum for class ith discriminant function, then that example belongs to class I. Okay, so that is the reason. That is the model.
Sir, not clear. Can you explain?
Okay, give me just 1 minute. Let me share the slides.
This least squares is quite confusing, even from the lectures.
Sir, can you give a real life example of least square? That would be better to understand, I feel.
Yes, sir.
Okay, can you see the screen?
Yes, sir.
Okay, so here we have discriminant function is a function that takes the input vector x and assigned to the k of classes. So discriminant function is nothing but you just think as the linear combinations of features. Okay, it's just a hypersurface of hyperplane in the m-dimensional space. Let's say you have two classes, so it's gonna be your plane. Okay, and so looks something like this. You have two features x1 and x2. Sorry, I mentioned the labels. These are features. So x1 and x2 are features. So your hypersurface is gonna be this plane, this line. Okay, so line itself is the m-1 dimensional space, and it is in the m-dimensional space. So you have two-dimensional space, input space, and your the separating surface, or say the decision boundary is gonna be your one-dimensional. That is line. Okay, so this is your what will be the equation of this? This is just linear combinations of input space, and now we have to learn this. You have to fit this line, this hypersurface. So for that you have to define your model. So first, let's see what are the important features of this hypersurface or hyperplane. Okay, so
just a question. So in your normal linear regression, right, that is also y is equal to w0 plus wtx, right?
Yeah.
So how is that different to least squares? Is it because we're equating it to zero? Well, I mean, I'm struggling to understand the difference between.
In the case of linear regression, again, this is motivated from linear regression problem. Okay, but the problem here is it's there. There in the case of regression, we have labels as the real number, so you can make the prediction using that line itself, right? But in the case of classes, these are not real numbers. Okay, if you make prediction as a real number, that gonna make no sense. You have to make some prediction as a classes, different classes. So that's why we are defining some different criteria here. Okay, in the upcoming weeks, you will see how these actually defines your probabilities, and you will define a threshold. On the basis of threshold, you just divide into different classes. That gonna be in the week 5. Here we are not doing these things. So remember few things about this hypersurface. First thing is that this surface is gonna be m-1 dimensional space, and the input space is gonna be m-dimensional. Okay, the surface itself is m-1 dimensional surface, but where the input space is m-dimensional space. So don't be confused within these two. Second thing is that here the vectors. One thing is bias. Second thing is vector w vector. So the bias is denotes the distance of the plane, distance of the surface from the origin. Okay, so this distance is gonna be your this is defined using W naught, the bias intercept. Okay, and the vector define the orientation. Orientation means that how it is lying. Okay, so so you can verify all these properties of hypersurface as well. So W0 determines the location because W0 gives you the distance from the origin, so it determines the location of the surface, and W, the vector, the weight vector, determines the orientations of the surface. Okay. So let's say you have 2 points x1 and x2. So on the surface, the value of if they are on the decision surface, then the value of this surface is gonna be 0. So W0, W transpose x1 is 0. Similarly for the checking point, 0. If you using this equation, if you differentiate this, you can see that W transpose x1 minus x2 is equal to 0. So here dot product is 0. It means what? This vector is orthogonal to this vector, right? W vector is orthogonal to vector x1 minus x2, and the x1 minus x2 vector, where it will lie? It will be on the surface, because both x1 and x2 are lying on the surface. So x1 minus x2 are lying on the surface. So W transpose is always orthogonal to the hypersurface. In that sense, you can say that W decides your orientation of the hypersurface or hyperplane in our case.
So one doubt, like in the regression, that least square, we get the line of best fit. We know the method, you optimize that, you minimize the loss function. Here, how do we get this hyperplane? This is not clear to me.
The model is okay. Now
so suppose we take an example of classifying of the fruits. Suppose we have 2 fruits, banana and mango. How are we getting these x1, x2? I mean, how are we classifying? Suppose if we do encoding also, how do we get?
We haven't made any prediction. We haven't made any prediction yet. So what we have done, we have just defined a surface that will separate those things. So how you will optimize such hyperplane? Let's see that.
How will we get that surface?
Yeah.
Okay. I'm coming to that
is
point.
The feature matrix, for example, a bunch of real numbers?
Yeah, I'm coming to that point.
Yeah.
I got your point. Let me share my screen. I will try to explain that. Okay, so you can see the whiteboard, right?
Yes, sir.
Yes, sir.
Yes, sir.
So let's say you have 2 classes, 2 features. Okay, so let's say you have 2 features, x1 and x2. These are 2 features. So this is your input space, and so your data point will be, let's say you have 2 classes, in class 0 and class 1. So these are your class 0 examples and class 1 examples, and these are your class 0 examples. Okay, so the examples are lying into M minus the space. So I'm interested in finding a hypersurface that makes that divides the input space into 2 parts. Okay, so how so this surface is gonna be your line, right? In our case, so if you are in 3-dimensional space, your hypersurface is gonna be plane, and if you are more k dimensional space, your hypersurface is gonna be k minus 1 dimensional hyperplane. Okay, so in our case, this is a line. This is 1-dimensional line, and the space is 2-dimensional. Now, so what will be the equation of this thing? This is your x1, this is your x2. You can simply say xy. So what is gonna be equation of this line? It is something y equal to w0 plus w1x, right? Equal to this thing. So you can say it is same as w0 plus w1 x1 plus w2 x2 equal to 0, right? Some constant you can again put here. So this is your hypersurface. So this is your equation of hypersurface. For m dimensional, you're gonna be hypersurface gonna be w0 plus w1 x1 up to w m xm equal to 0. So this is your hypersurface, or you can write it as w0 plus w transpose x equal to 0. So remember 2 properties. W0 defines the distance from the origin, and W transpose defines the orientation, right? So always remember these 2 points. W0 determines the location, and W transpose determines the orientation of the surface. Next, now our next task is to how to optimize this. For different sets of W's, different set of W0, this can be anything. This can be this hyperplane, I mean this line, or anywhere it can be, right? So how to find this one? For this, you have to define in loss. Okay, how to define the loss for before coming to the loss. Let's say you have somewhere one point is there, right? Y is here, one point x1. Let's say so the distance W0 plus W1 x1. So this gives you the distance, sign distance of that point x1 from the surface. Okay, so this thing, let's say this one is your y1. So this will give you the sign distance of that point from the hypersurface. Okay, remember this point as well. Okay, so how you will define your loss?
Sir,
Yes.
sir, unable to understand, sir. This is what is orientation, sir, in this. Sir, can you explain this by taking, sir, please listen. Can you explain this by taking a line y equal to mx plus c? Like if you draw the line mx plus c in 2D, so y will, the vertical, this will be y values here. So horizontal, this will be the x values. Can you explain this by taking that example, sir? Since this became, I am unable to understand, sir.
So you, so this you're saying this is your x, this is your y, your surface is gonna be something ax plus by plus c equal to 0, right? Some line, it's gonna be some line.
Sir, how this will be surface, sir? You written here ax plus c equal to 0. How this will be surface?
This is a line in this case.
Sir, one thing. Equation of line is y equal to mx plus c. So this line which you have drawn, this is cutting y and x. This is line y equal to mx plus c. Yes. Then if you replace here m with w and c with w naught.
Okay.
Okay, sir. So how many features are there? There is one feature.
Form. This is the standard form. This is the general form, right?
Yes, sir. Yes. Clear.
Yeah.
So can you, sir, now explain this by using y equal to mx plus c? If you replace m with w1 and c with w naught. Now can you further explain what you have just explained?
So in
that
this
case, will be more clear, sir.
In that case, this will be different thing because I'm taking very general form. So general form you can take as here it is x2 and x1, right? So your general form says it is w0 plus w1 x1 plus w2.
But
x2
sir,
this general form.
Then what will
if
be
you
labeled
convert
here,
this
sir,
into this thing, if
sir, then what will be labeled here?
Huh?
What will be labeled here? If you are taking
we are
the general
defining surface. We are defining the surface. We haven't talked about the label here. So let's say you have x1, x2, and your label. So x1 some values, x1 some value. Let's say 2, 1, minus 1, 2, 3, 2, and label will be, let's say this is class 0, this is class 1, this is class 0, something like that. Okay, so okay. So what's happened here?
Sir, you have taken then y equal to 0 here, na? So you are taking only one level here.
Huh? So in this example, 2 comma 1. So 2 comma 1 somewhere here. This belongs to class 0. Minus 2 comma 2. Minus 2 comma 1. So here minus 2 comma 1. Minus 1 comma 2. Somewhere here this will be class 1. Okay, 3 comma 1. 3 comma 1 somewhere here. Right. So these are your data points. Now what's my target? My target is I need to just find one surface that differentiate within these two classes. Okay, this I'm to find. How I can find this? Okay, so that's what we are gonna do in the loss function. Idea is clear. Ideas will be clear what we are doing.
Idea is clear, sir. Can you start with the loss function also?
Okay,
Can you complete the loss function?
Come to the loss function. Okay, so it is not completed yet. Okay, let me explain.
By the way, sir, how was dividing by the norm giving you the distance from the origin? Just maybe a basic doubt.
So what is the distance? Let's say you have a line ax plus by plus c equal to 0. This is your line, right? So how you will find the distance from the origin? It's simple, right? It's just let's say not just origin. Let's say you have point x1 by 1. So how you find the distance? It's simply ax1 plus b by plus c upon root over a square b square, right? You must have done this in the maths 1 course.
Yes, sir. Yes, clear.
Yes, sir.
Yes, sir.
Okay. Okay. Thanks.
So that's why we call W node upon norm of W. Norm here it is norm 2. So this is your distance from origin. Okay, so now let's say this is a hypersurface. Some points are here. Some second class points are here. Now, so this is gonna be your y1. If this is the point x1, if this is the second point x2 example, so this is your gonna be y2. This is gonna be y3 if this is the third point. Okay, so what I'm doing, I will let's say 1 point is here, so which is misclassified. Okay, so this is your, let's say this is the fifth point, and the distance is by 5. Okay, so what this distance I will calculate. So this is gonna be your by 1. So by 1 minus the classes. Okay, so error gonna be your error associated with the ith example gonna be what is predicted minus what is actual gonna be classes, and predicted here in this case are gonna be distance from the hypersurface. Okay, so this error gonna be squared, and we want to minimize this. Okay, so if you minimize this, you will get your weight vector. So this loss gonna be your ZW is gonna be sum over E, so sum over E squared. If this is not a square, then this in the case of vector you can write it as E transpose E, and the same thing you will get. Let me share the slides first.
Sir, how do we get the distance of each point from the hyperplane? Distance of each point from the hyperplane, y1, y2.
So that's how you define the distance, right? How you define the distance of a point from the any given hyperplane or hypersurface?
Like what is the formula? How do you find it actually?
How do you find it actually? Let me check it. Your line, this is your point.
Hello, sir, you are not audible.
Am I not audible?
Yeah, you are audible, sir.
But sound is very less.
This distance we need to find, right?
So I can't hear you.
Sir, we cannot hear you. Hello, sir.
Yeah. I can. Hello. Am I not audible?
Sir, volume is very less.
Still it is less.
Yes, sir. Very faint. It's like.
I'm not sure about the proof of this, how we get the distance. I have to check. I'm forgetting how we prove it. It's a mathematical part. We have to check it. Okay, you can refer to some other books, mathematics books. So now just remember that this gives you the distance from the point to a hypersurface. This thing, okay. You have been given 1 point x1 by 1 and this hyperplane. Then the point distance of the point from the surface is ax1 plus by1 plus c divided by norm of norm of this surface. So this is gonna be a square plus b square. So this decides your distance from the surface of the point. Okay, and how it's coming, I don't remember exactly. I need to check it. So now you can just remember this gives you the distance.
So this distance, if it is greater than 0, then we classify as one class. And if it is less, then we classify as the other.
Negative, then we are the other side of the plane, and if it's positive, we are the opposite side of the plane, right? One side of the plane.
Okay.
Okay, so that's how we classify into different classes.
Okay.
Looking at the sign of the distance.
And then we are comparing it with the actual class, and then seeing the error.
Yeah, error.
That's the loss function.
Loss. So we are minimizing the distance. So what happens when we minimize the distance? So if we are minimizing distance, means if some example is misclassified, then the distance from the, let's say this is your misclassified point. So if we are minimizing this distance, it means it will come closer to the hypersurface, right? So that's what we want. If we reduce this distance, then there will be chances that it will be classified correctly. So that happens if that's why we are minimizing the sign distance. Okay, the distance of the points from the hypersurface.
But sir, how can we bring the points, because the features are fixed, right? So how can you change the points?
No, you make use of that different examples. You have been given the data sets.
Okay.
Okay, so let's say for your exam, your hypersurface is W0 plus W1 x1 plus W2 x2, right?
Yeah.
So this is your hypersurface. Now for first example, let's say x1 is 2, x1 is 2, x2 is something 1. So for that, your surface is gonna be W0 plus W1 plus 2W2, right? Something like that. For second example, something like that. Okay, so for such an example, if you have n examples, you for on all such examples you find the error.
Okay.
Okay, and you try to minimize that error.
Yeah, so minimizing that error would be by changing the points, is it, sir?
No, by changing the decision line.
The weight.
Right?
Because
line, right?
You are actually finding
line
W,
will change. Yeah.
Line will. You'll change the weight. So that will you'll change the orientation and the location.
You are finding WIs, not the XIs. XI are given to you. These
Yeah,
are
they are
features.
fixed. Yeah, that was the confusion for me.
You are finding WIs, not XIs.
Okay, okay, sir. Yeah. Fine, sir. Thank you.
So our task was to go through the collab, but we are wasting time on other things. Let's go to that. Okay, so this is the idea behind least square classification method. So here it is not the matrix, it is gonna be the trace of matrix. And how you will optimize this, you have to find the minimum of this. So two methods are there. One is normalization. You just take the derivative of this and equate to 0. In that case, is W is gonna be the trace of this matrix. Okay, it's not just the matrix, it's the trace of matrix. And the second method is optimization, that is gradient descent. So there are 3 versions of gradient descent: stochastic gradient descent, mini-weight gradient descent, and simply gradient descent. Okay, so in that case, what we'll do, you just start with some random weight vectors, and then you update your weight vectors in the direction of local minima. You have some function, you have some loss function, so you try to move in the direction of minima, global minima. Okay, so that is the idea behind optimization. In the case of multi-class, what happens, you rather than defining
so 1 second. What is the meaning of the first line? Yeah, in inference, the bulleted line, we return the class label.
The largest page of linear combination. So what you actually do there? So actually, what you do, rather than defining this one simple discriminant function, you define k different discriminant function. Okay, and you will check the values of, for a particular example, you will check the values of all such by i's, and for which it is maximum. Let's say if it is maximum for by k, then you will define that example to be for class k. Okay. Is it okay or not?
So that means like we have a K equation of hyperplanes, and the one which largest value of
one with the largest value, you will just define that example to belonging to that class. If it is maximum for class 2, discriminant function 2, then you will predict that example into the class 2.
Okay, so how, like, what programmatically which step is doing this?
You mean in the code?
Yeah, in the code.
Okay. We will come to that. Okay, so for multi-class, what you will do, you just define K classes, K discriminant functions, and you will check for which discriminant function the value of maximum. You will just predict that example belonging to that class. Okay, so in the next step, we are gonna the same thing. Here we defining the class least square classification, and here we are first defining the initial learning rate to be 20, and we will update our learning rate according to some manner. There are different ways to update your learning rate. There can be constant learning rate as well. There can be adaptive learning rate. There can be inverse scaling learning rate. Different types of learning rates are there. You will come across this in the course of MLT. Okay, so here we are defining learning rate, initial learning rate to be 20, and we will decrease our learning rate depending upon how your model behaving. Okay, so first method is predict method. So you have been given the array. X is your n-dimensional array, that is feature matrix, and W is gonna be your weight vectors. Okay, so
Sir, here we are not adding the dummy feature because we are treating W0 separately. Is it so?
No, you have to add dummy features into X.
Here also we have to add?
Yeah, we have to add.
Okay.
Okay, so first you will check whether they are we can they are compatible for matrix multiplication or not. So you will check the columns in X and number of rows in the W. If they are equal, they are compatible for matrix multiplication, and you will just find X into W and will check the maximum entries, the column at which it occurs the maximum, right?
So this is the maximum, the linear combination, is it so?
Yeah, so that will give you the predict. So you will check where the maximum occurs.
X is equal to -1 means?
X is equal to -1 is the, I think you will check along with the columns.
Okay.
So in the columns, you will check at which row the maximum occurs.
Okay, sir.
Okay, so
till now we had studied about X is equal to 0 and 1 only.
X equal to 0 and 1.
Yes, sir. Is -1 axis?
-1 is the last axis, right?
Yeah,
the last axis.
Last axis.
Okay.
That is column.
Okay.
So what does Rmax do? I mean, I'm still sorry. I'm still not clear about R.
Maximum will give you the maximum entry, but Rmax give you the index at which the maximum occur.
Yeah. So what do we do with that? I mean, that conceptually that's not clear to me. I mean.
Okay. So so you are able to see in my entire screen or just this collab file?
Just the collab file. Also some pages.
Okay. So let me share the white. So let's say you have XW component. You have X into W. Okay. So in XW you are coming something like that. 0.2, 0.5, 0.8, 0.1, something like that. So this is the value corresponding to first discriminant function. This is value corresponding to third discriminant function. This is value corresponding to the last discriminant function. So your predictions will be what? You will check at which entry or at which index the maximum occurs. So maximum occurs as the 0th index, first index, and the second index. So that examples belongings to class 2 because the maximum is occurring at the second index. Right?
So does that mean the distance is maximum from the third class? I mean, what does that mean when you say maximum is taken?
Yeah, distance is maximum with from the third discriminant function.
Okay.
And in other sense, you can think these as the probabilities. The probabilities that it will lie to class 1, class 0. This is probability that it will lie into class 1. So for that, we are making some assumptions. You will see into week 5. Okay, when you will come into the logistic regression, this idea will be clear to you. Why we are calling it the probabilities. Okay.
So basically, the maximum distance shows us the certainty of it being in one certain class, right?
Certainty. You can say there are more chances that it will be correctly classified to that class.
Yeah.
Okay.
Okay. So.
But still, in this predict, we are finding predict. So we are trying to predict the label.
Yeah, predict the label.
So here we are saying that if it is having the highest weight, then it.
Okay. One thing I missed it. That x into w gonna be, it's not a label, but it's gonna be back to side. X into w gonna be n cross k matrix.
Okay.
Okay. So I made a mistake there, right? So let me correct it. So x into w is gonna be your n cross k matrix, right? So the first will be the weight vectors for the you will have k discriminant functions, right?
Right, sir.
Right. So this belongs to so n here will be n rows and k columns. So this will be the weights for the k. So this will be the weights for first discriminant function. So so let's say these are your ith column. So this is gonna be your weights for ith discriminant function. Okay, and these are gonna be your weights for last discriminant function. So you have k discriminant functions. K columns will represent the weights for the k, and this is gonna be n plus 1, right? N plus 1.
Right. Now it's clear.
Okay, so n plus n, sorry, not n plus 1, n. So you will have entry something like that. So you will check along
the column with the largest weight.
Something. Okay.
Along the row.
Okay. How you can make prediction.
Will it be row or column? Because every column is a separate
It says
discriminant.
axis -1, right? So it will become each element. Right? Each element will be the. I'm just guessing. I'm thinking because it says axis -1.
Yeah, I'm still confused.
Okay, so
actually, I think we have k classes, so it can be one among the k values. So for each row, either 0 to k minus 1 or something
so
like that.
X into W is gonna be your n cross k matrix. Here you have this belongs to first example. This belongs to second example. This belongs to let's say you have three examples and 3 classes. You have 3 cross 3 matrix. Okay. So this row belongs to first example. This belongs to second example. This belongs to second class. And values here. So this values first value will be the values for the first discriminant function, right? So this is gonna be your, let's say your weight w10 plus w1 1 x1 plus w12 x2. This is your first discriminant function. Second discriminant function is w20 plus w21 x2 plus w22 x2 equal to 0. This is your second discriminant function. Third will be w30 plus w31 x3 plus w32 x2 equal to 0. These are your third discriminant function. Now this entry will be corresponding to this one. So your, let's say your first example is x1 x1 plus x1 is 5, x2 is equal to 3, right? So this value is gonna be your w10 plus w11 5 plus w12 3. Okay, so this entry is gonna be this value. Okay, and this entry will be corresponding to this discriminant function, and this entry will be corresponding to this discriminant function. So how you will make prediction which value is maximum, right? So you will check in every rows for along with which index the maximum occurs. So if let's say maximum occurs for the first discriminant function, second discriminant function, so you will classify it into the first discriminant. This is 0 discriminant function, first discriminant function, second discriminant function. So if the maximum occurs along with the first entry, you will classify into the class 1. So this is your example 1. Again for the second example, let's say second example is x1 is 3, x2 is 7, something like that. So these entries gonna be corresponding to this, and corresponding to this thing. Okay, so you will check for which it is maximum. Let's say this is maximum for this thing. So you will classify second example to be class 0. Again, the same thing for the third example. Okay, so that's how this function is working. Is it clear now?
Clear, sir.
Clearer.
Yeah, so now look at this function. Here it will check, it will find x into w, and along with the each row, it check where at which index the maximum occurs, and so that's how it's making the prediction. Okay, the next method is predict internal. So rather than predicting the classes, it will predict the classes in the encoded form, encoded matrix, right? So rather than just giving you the classes, it will give you the x into w. So how you will define the loss? Loss is just, if you go there, loss is defined as y minus xw transpose and y minus xw. And if you have regularization, then lambda by 2, w transpose w is gonna be there. So the loss
Just
is
a quick
defined.
question there. So in linear regression, we have used xw minus y, and here we're using y minus xw. Does it matter, or is it?
No,
by...
it won't matter. It's just a square thing, right? E transpose
because we're
V, so it
squaring.
won't matter. Yeah. Right. So loss, you have been argument will be taken as x feature matrix. Y is again encoded. Y is gonna be encoded level vector. And regularization rate will be given as reg underscore rate. So error gonna be y minus predict internal x. So remember predict.
Please don't scroll. Actually, I was having error in this one. So.
You can later pause it and you can check it, because we are very behind. We already wasted 1 hour.
Okay, sir.
We have to cover more things. Okay. And again, we have session on the Saturday as well. So if doubt is not clear, you can ask in the Saturday session. Okay. So this how your loss is defined. It's just the expression half of E transpose E plus lambda by 2 W transpose W, right?
There is no trace calculation here, sir. It's just a simple multiplication.
Yeah, that is the mistake here. Remember, it's a mistake in the lecture. I'm not correcting here because these are the columns that sir has access, and if sir will allow, we will make corrections. Okay, so it is not actually matrix. Is gonna be the trace of that matrix. Okay, so next method is fit. Again, the argument are feature matrix, label vector, and the regularization rate. And so, so what is the fit here? So W is gonna be x transpose x plus lambda I, x transpose x plus lambda I inverse, and x transpose y. Right. So the same expression is written here. Solve the equations. Lambda I plus, so actually this is nothing but
Sir, I'm not able to hear you.
Actually, I've muted myself. Okay. So what I was telling. So this is the solution of x. What is the solution of Ax is equal to b? What is the solution of a system of equation Ax is equal to b? Let's say you have system of equations Ax is equal to b, right? So what is the solution of this? X is equal to A inverse b, right?
Right.
So similarly, if you look at this equation, this equation, so this is the solution of what? Just compare X inverse b. This is your b. A inverse b. So this is the solution of take this thing as x a. Sorry, this thing as x a. This thing as a, and this thing as b.
So here we can use P inverse also.
Yeah. So this is the solution of a x, and this is your b. So this is the solution of the system of equation of type Ax equal to b.
So instead of solve, we can dot solve. We can use P inverse also.
That again you can use. Same thing. Okay, so this is how your normal equation will give you the solution. Second part is gradient optimization using gradient descent, right? So should I go through this course, or you have already done? I think you have already done this course in week 3 or week 2. So I think I can skip this course. Gradient descent. Yeah, learning rate here. What's happening to the learning rate? Initially it's T0, and after one epoch or two, after every epoch, it is reduced by this factor T plus T1. Remember T1 we have already defined as 2000. So every time it is reducing by the factor 2000.
So this way, the Perceptron class is not clear, sir. If you can.
Perceptron I haven't decided. Haven't come to the Perceptron.
Okay.
From it is same as the other things, right? Linear regression.
Yeah, linear regression. The other course is exactly same that we have covered in week 3.
Okay, then it's fine.
Right. So this is the demonstration. You can check it. I'm just scrolling down. So if you haven't seen this collab, you can pause it and you can check the collab file. Okay. Everything is clear in this. There shouldn't be any problem.
So this pre-process function, sir has written it in the beginning also, right? I mean, what difference is there between this pre-process and the previous one?
Previous one, in any other week you're talking about?
No, sir. In this collab itself, if I go above, I believe there is one more pre-process function.
No,
defined.
here it is polynomial transformation.
Okay.
This is for polynomial transformation and level encoding.
Okay, there's no pre-process, is it, sir?
No. Here in pre-process, we are generating toy data set and just splitting into train and test.
Train and test, yeah. Yes, sir. So, and in that pre-process itself is where we are adding the dummy feature, right?
Yeah, dummy feature.
Okay.
The dummy feature gets added in the polynomial transformation code itself.
No, if you're not doing polynomial transformation, you have to add dummy features. Because if you're not adding dummy features, you are skipping the intercept. That you cannot do, because if you are skipping the dummy feature, skipping the intercept, then it means you are learning only those hypersurface which are passing through origin. That we don't want.
No, I'm saying just in this collab, because he's got polynomial transformation up top. I just said dummy features were being added as part of that code. But I understand, dummy features have to be added.
Yeah. Okay, so you can go through this course and you can check. All this is covered in lectures as well. The new things are the concept the model loss function and how to optimize the loss function. The different examples for that. Okay, so just tell me what happens in the perceptron model. If you have if you have gone through the lectures, what is the concept behind the perceptron model?
The label will be only binary.
Okay. Any other thing?
Well, it's very similar to the thing that you have WT phi of x, and then the output, if it is greater than 0, you classify it as +1, otherwise it is -1.
Okay, what is the model there?
It's a function of
binary classification.
You use sine function, WT.
Sine of WT phi x.
Sine W transpose phi x.
Okay. Let's look at the perceptron now. So one thing about perceptron is it's only used for binary classification problem, and perceptron will be used only for linearly separable data. If your data is not linearly separable, then the model will not converge. Okay, but you can also apply on non-linear separable data, but you have to stop at some point of time. It will not converge by automatically, but you have to stop your iterations after some time. Okay, that you have to predefine. But in the case of linearly separable data, it will be automatically converged to the optimal solution. Okay, so the training data is the same thing. The data matrix is X of the shape n cross m and n examples m features. The label vector is of size n cross 1, and each entity belongs to the class -1 and 1. Now, so model is what? You just take the linear combination and then followed by a non-linear activation function. In the case of activation function, here we have the threshold function or the sign function. So if the linear combination is greater than 0, then you will define it to be class 1, and if it is less than 0, then class -1. So remember, linear combination give you the sign distance. If it is greater than 0, then you are on the positive side of the hypersurface, then you are defining to be class 1, and if it is less than 0, it means that you are the other side of the hyperplane. it means that you are defining it into the class -1, right? The same thing now. Signum or sign function is the way how you write the activation function for the perceptron model. So how you define the loss here? In the case of loss, you define, so first error. So if it is correctly classified, let's say if it is by head equal to by, it is correctly classified, then you will error will be 0. And if it is incorrectly classified, the error gonna be your linear combination plus linear combination into that value, because remember this value is either -1 or +1. So if it is not equal, then this values into -1 will give you the positive quantity, right? So it is the maximum of all these things. You can verify this thing. It is in the slides. You can also verify these two things are similar things. Equation 5 and equation 4 are the similar thing.
Sir, why we are referring here as phi of x instead of x itself? What is the difference?
Phi of x is the linear transformation. The polynomial transformation, sorry.
But previously also we are doing the polynomial transformation, right?
If your data is not the you cannot learn using the linear surface, then you have to transform into the some other transform space, polynomial space, right? Again, you can start with the linear transformation here. You need not to do the polynomial transformation if your data is linearly separable using linear discriminant function or linear functions.
Okay.
So the total loss will gonna be your sum of all these errors.
But it's not really the negative of linear combination, right? It is the negative of sign of linear combination, or rather the sign of the linear combination. It says minus W transpose phi of x, right? But it's really -1 or +1, right? That's all you will have.
No. Again, if you apply the signum threshold function to that, then it is +1 or -1. But for finding the error, we are just finding this value. This value will be actually nothing but the distance of that point.
So that can be any real number, right?
Yeah, it can be any real number, but most probably it's gonna be in between 0 to 1.
Okay.
Okay. And again, this is the distance of that point from the surface, right? The same thing, linear combination.
Okay. No, I thought the error can only be 1 or 0. That's what I thought. But if
in another way, you can also think as the sum of number of misclassified points. Okay, this is again a different way to look at the error in the case of perceptron. But in that case, how you will minimize that thing? How you will use your optimization procedure? If you have just number of, let's say you have 10 error 10, it means you have 10 misclassified points. Now, how you will optimize that thing? It's not a function of W, right? You need to have the value function of W to optimize this.
Right.
So for that, we are taking the distance of that point from the hypersurface. So these are the sum of distance of those points which are misclassified.
Okay.
Right? So in this, in how you will optimize this thing. So the idea of that is, let me show you that. Now I don't have the slides. Okay, so slides are given in the portal or not?
Only lecture slide are given, sir, not the collab slide.
Okay, so here the idea of the optimization is that, let's say at some point of time, this is your hyperplane. Now this point is misclassified, then you will corresponding to that vector, you will move the surface into that direction so that that point will be classified correctly. So that is the idea behind the convergence of the optimization. So how you will optimize? So you will just update those vectors corresponding to which points are misclassified. Okay, so remember, if here WT plus 1 is WT, this is the weights at the tth iteration, and alpha is the regularization rate, and pi I is the actual level, by hat is the predicted level. So this will be 0 if they are correctly classified. So you are not updating those weights for which the points is correctly classified. Only you are updating only those weights along which the points are misclassified. Okay, and remember, if you are adding two vectors, you are moving into that point's direction, right? So, and W decides the orientation of the plane. So if you are changing W, the orientation of the plane will be changed. So look at this image. If at a particular iteration, this is your plane, this is your hyperplane. So some points are misclassified. So if this is misclassified, you will just change the weight into that direction. So your orientation of the plane will be changed. So that's how the plane will keep on moving until the all the points are correctly classified. So this is the idea behind the perceptron model. You just keep on changing the orientation because you are updating the weights only. So in that way, you just check the misclassified point, and you will correspond to weights. You just add that point into the weights. So the weight will be moved into that direction, and the point will try to come into the correct region. Okay, so that's what happens in the case of perceptron. Now, if you look at the codes here, again the implementation here we have importing the libraries, polynomial transformation we have already seen. Here we defining class perceptron. So predict is what? X into W. So prediction will be what? It will be 0 if it X into W is 1. Or if it is greater than 0, then you are predicting to be class 1, and if it is less than 0, you are predicting to be class -1. The same signal function we have defined, we have just seen, right? How you are defining loss? Loss you are defining as the maximum of minus of X transpose minus of, what was that? I just forget what was that.
XW.
Loss is defining as minus of X i's, Y i's, and zeros. So this is the maximum of, this is how you define the loss function. It is just the expression, right? So maximum of X, Y into X, Y, and 0. In training, we are updating the weight vectors. So initial weight vector, we are starting with zeros vectors, and then a 0 vector means that you are at origin.
Sorry, sir, in this loss function, that's going to return only -1 or +1, right? So it's not going to be returning any 0 to 1 real numbers. Because if you look at the predict function, it is returning only 0.
Yeah. In this case, it will give you the number of classified points.
Okay, so this loss is going to be just -1, +1, or
yeah, exactly
0.
Sum of, right?
Sum. So
Sum
it will
of,
give the number of misclassified points.
Misclassified.
Yeah, exactly, it's correct.
Okay.
But for optimizing, I think you must have as a function of W. So I will check whether it is correct or some mistake is there. Let's look at the train function here. So you are initializing a W with the 0 vectors and empty list to track your weights for different iterations, error and the weights.
What is that underscore?
Sorry?
What is the underscore in that 4 underscore in range?
I didn't get to that.
Why are we not giving any 4i in range of epoch? That for loop.
Okay, this you can write it as I. This you can take for I in the range.
So underscore is kind of variable name?
No, not exactly.
What is the
So
meaning of that?
she's asking instead of that underscore, can she use any other iterator of I, A, anything, any other variable name? It's basically an
So
iterator,
because
right?
it's not used anywhere else, so it's
Yeah.
going to run through as many epochs. So underscore IA, everything will work, I think. As long as I
Anything,
is not used.
any variable name will work here. Not any
Yeah,
specific about underscore.
Okay, like I'm asking whether underscore has any specific meaning.
No, nothing.
Okay.
Sir, and what does zip do?
Zip just take the tuples of these things. Tuples of these two lists or whatever variables are here. It is list here. It will give you the tuple kind of thing.
Okay.
Where first element will come from X and second element will come from Y.
Okay.
Okay. So X size will be X and target will be Y, right? So it's again the how you will update your weight vectors. So it is the W, you will add just W plus learning rate into Y minus Y hat, right? So this is your Y hat and into Xi. And so error gonna be your, so this error I have to check whether it is correct or not. In this case, because we are defining predict, we are defining as the classes. Yeah, here predict will give you the classes, not the distance. Okay, so here error is the number of misclassified points.
But sir, this is the way the error has been defined even in the slides for Perceptron.
Okay. But in some books, I see that error can be defined in both the way. If you look at the graph function of the loss function.
If you take errors like this, then there will be huge variations, right? Because every time it's going to be 1 or 0 or 1 or 0. Whereas
summing over those will give you the number of misclassified points.
Yeah.
So now look at this image. Can you see the image?
No, sir.
This image. So here loss is defined as a function of W. Okay, so
yeah, I was wondering with this about this because here loss seems to be a real number. Oh,
yeah.
Okay.
So it is just the sum of it is not just number of misclassified points. It is the function of W, right? So it is 0 after it is positive.
Yeah, it seems to be continuous.
Okay. Okay, I will check, and I think both the ways are correct to define the error in the case of Perceptron. You can go with both the way. Okay, so let's move ahead. So this is done. You are updating your weights vector in every epoch, and keep track of this in the list of this. You have defined error all and WR. Next, again the same data toy data set we have used for demonstration. You can see this codes. Remember, always it will converge only if the data is linearly separable. If it is not linearly separable, the Perceptron model will never converge. So you have to stop by yourself. You have to define number of iterations to stop it. Okay.
Sir, for linearly separable, after all the epochs, all the weights will be the loss will be 0, or how do we confirm that it is linearly separable?
Yeah, if you are defining loss as the number of misclassified points, then loss will be 0 after some point of time, after some number of iterations. And if the loss is defining as some function of W, then it will be very close to 0, not exactly 0.
Okay, if it is like here, we have defined it as like sum of things, right?
Yeah, so in that case, it's gonna be 0.
Okay, but we have to check whether it is oscillating or it is converging, right?
No, after some point of time, it will converge to the optimal solution. It will not be the case that it will oscillate surface somehow. Will definitely will converge to the optimal.
So your voice is not feasible.
So I'm saying that after some iterations, the perceptron model will converge to zero. It's not the case that it will oscillate or will keep on oscillating.
I can't
Sir,
hear
your
you.
voice is not clear.
It is not audible or very low voice.
Sir,
Very low voice.
No, sir.
Very, very faint, sir.
Is it better now?
no, sir.
No, sir. No, sir. No, sir. No, sir.
Hello. Hello.
You are still not audible, sir. Your voice is too low.
Hello.
Think you're better now. So can you keep talking?
Is it better?
Yes, sir.
better.
Okay. So can I share screen now or not?
Yes.
No, I cannot. Just give me 1 minute. Okay, now I think. Okay, so now let's move to the activity questions of week 4. Then let's start exercises. So questions are rather easy for this exercise. So
before that, one small question regarding the perceptron linearly separable case.
okay.
We will find the errors in each epoch, right?
Yes.
Yeah, how do we confirm that it's the last error? We should check whether it is 0 or after some amount of epochs, all the errors should be 0.
So all the error means what? We are finding total loss, right? So total loss means total error. Total number of misclassified points. So after my point is that after some point of iteration, some number of iterations, the total loss will become 0. So in between iterations, it may happen that your error may go up and go down, right? So it may happen that if at some point or at some iteration your point is correctly classified, and that one may misclassify in some of the iteration. So it may happen because your surface, actually your hypersurface is orientating, moving or say orienting around some points. Okay, it's just moving into the space.
Okay.
So, but after some iterations, it will converge definitely.
Okay.
Okay,
Actually, it is a graded question, so I don't know whether I can ask more.
Okay. It's a graded question.
Graded programming question, last one.
Okay, we'll check on that. Okay, so let's move to the activity 4.5. So first question is very easy. Discriminant function generally learns the direct mapping. So direct mapping is we are finding the surface which divides the input space into different spaces, different parts. Okay, so that is direct mapping. In classification setup, the class level is classification. It is a discrete quantity. So what is the order now here? So linear regression, logistic regression, support vector regression. So what will be the order now here?
Except linear regression, we don't know the other two. So I guess it's
Okay,
logistic.
so logistic regression is used for classification. Support vector regression is again used for regression. So this one is used for classification and these two are used for regression. So the second one is the odd one out here. Okay, so fourth question is asking which of the following is or are correct regarding classification methods. So classification and predictive modeling is the task of approximating the mapping function from input variable to continuous output variables. No, in the predictive modeling, we just make the models, classification model using some probability distributions. Okay, so that's why first option is not correct. Second says that generative and discriminative model has conditional probabilities and assign a label based on that. Yeah. So generative uses generative classification use the base. You make use of base theorem. That is, if the conditional if p by given x it's given to you, it learns the conditional probability distribution by given x using base theorem. That is, p x given by will be given to you. And using base theorem, you will find the p by given x. So generative models do. In the discriminative models, you make some predictions about the models, parameter models. Let's say you assume that your data is coming from the Gaussian distribution, something like that, and you learn those parameters of distributions. Okay, so these are the difference between generative and discriminative models, but both learn the conditional probabilities by given x. So instance-based models compare the test example with the training examples and assign the class. Second option is correct here. The instance-based models compare the test examples with the training examples and assign class label based on certain measure of similarity. So this is correct. So what is examples for instance-based model is the k nearest neighbor. So what happens there? In the k nearest neighbor, you just let's say one test data set is there. So in that point, you will check the nearest neighbors. Let's say three nearest neighbors, and you will check whether the nearest neighbors are belong. Most of the, the most neighbors are from class 0 or class 1. According to that, it will assign the labels. So it every time a new examples comes in, it checks the distance, some similarity or dissimilarities in the neighbors. So that is called instance-based. By instance-based, because every time a new examples come, it again check the measures of similarity or measure of dissimilarities. That's why it is called instance-based models. Okay, examples like KNN, let's say K nearest neighbor. And discriminant classifier uses parametric models. Here again, we have discussed discriminative assume some distribution that the data set is coming from the Gaussian or some other distributions, and we try to learn those parameters. So those are called discriminative classifier, and generatives are just make use of the base theorem to find the conditional probabilities. So the fourth option is again correct.
But first option is not showing in the question is correct.
First option is not correct, right? Predictive modeling just make the direct mapping is what we don't learn the mapping function. We don't learn any discriminant function, but in the predictive models we learn the probabilities. We don't learn any hypersurface or hyperplane.
Okay.
So which label encoding scheme is used in multi-class setup? We have just used that one hot encoding is used for label encoding. Which of the following is correct regarding the label representation? In single label representation, label is a scalar quantity, yes, and the single label, each and every example is associated with only one label, right? But in the multi-level classification, any example can be associated with more than one label or more than two labels or two labels, right? And in multi-level classification, always more than two binary labels are present. More than two binary labels are present. Only more than two. Okay, so there is some confusion in this statement. This needs to be rectified. I think this statement doesn't make any sense. Okay, so it should be in multi-level classification. Either every example associated with more than two labels, or more than 2 levels are present, something like that. So this statement doesn't make any sense. So I will check it and will correct it on the portal. Okay. So we'll consult in with the team. And the third option says that in multi-class classification, each sample is assigned to one and only one level of target. Yes. In multi-class classification, we assign only one exam level to each and every example. But if it is multi-level, then more than one level can be assigned to an example. Okay, but multi-class means that there are more than 2 levels are present. Okay, so any doubt in 4.1? Okay, so let's move to the activity 4.2. Geometrically, the simplest discriminant function by equal to W naught plus W transpose X represent. So what will be the answer here?
M minus 1.
M minus 1.
So surface itself is M minus 1 dimensional hyperplane. But if we are asking the space, so the surface inside the space M dimensional space, right? Remember, if we have 2 features, then the space is 2 dimensional, but the line is only 1 dimensional. In a binary classification setup with M features, the simplest discriminant function is very similar to linear regression. Actually, this discriminant function is actually motivated by the linear regression itself. The normal distance of the from the origin to the decision surface actually it is given by W naught upon norm of W. The norm here it is the that norm, second norm. What is the name of this norm? We have some particular name for this norm, right? Okay, so I'll check it later. In binary classification setup with M feature, discriminant function is very similar to the equation. Which are it's very easy to see. Y is the level vector here, and so Y is feature vector. It is incorrect. W naught is Y. This is correct. W transpose is the weight vector. Yes. X represent the level. X represent the feature matrix. So only 2 options are correct. Which of the following are correct about the decision boundary? So a decision boundary is a hyperplane that partitions the underlying vector space into 2 sets, one for each other. Yes, decision boundary is the surface, hypersurface or hyperplane. If it is a linear discriminant function, it is going to be linear surface. And if it is, let's say, quadratic discriminant function or more some other discriminant function, then it can be any hypersurface. But here we are only concerned with the hyperplane. That is, we are learning only linear discriminant functions. If not, then we will just transform a space into some polynomial using some polynomial transformation, and again we learn the linear discriminant function. So if the decision boundary is linear discriminant function, then the hyperplane is actually hypersurface is actually hyperplane, and it always partition the vector space into 2 sets, one for each other. So Cola file will not be shared with you. Second option is if the decision surface is a hyperplane. In the classification problem is here, yeah, the same thing I discussed here. If the surface that you are finding to separate to partition your space, if it is hyperplane, it means that you are able to linearly separate these 2 classes, and your classification problem is the linear, because only linear discriminant function can be hypersurface. Other quadratic or other discriminant function, like quadratic discriminant function, will not give you the linear surface. It will give you some different hypersurface. So second option is again correct. Assuming the number of classes to be 5, then in 1 versus 1 number of discriminant functions per pair of classes would be. So how many discriminant functions will be learned in 1 versus 1?
10, 5C2.
1 versus 1 means how many pairs you can make, right? 5C2 pairs you can make. So that will be 10. Assuming the number of classes to be 5, and the strategy is 1 versus rest. So number of discriminant function will be what?
4.
N, right? 1
4,
versus
sir.
rest.
1
4 or
versus
5?
rest will be 4. 1 k minus 1.
K minus 1 or K?
Okay, it will be 1 versus the rest. Rest will be 4.
K minus 1.
Okay, last one will automatically will be left, right? Okay. Okay, so 4.2 is done. 4.3. Sum of a squared error. Sum of a square of errors between actual and predicted levels of each training point is known as. So this is sum, so it's obviously not gonna be mean to total loss. Which of the following error function is generally used for classification method? Least square classification error is used for classification method. Actually, these options doesn't make any sense, and in some of the cases, mean can also be used. So this question again is not up to mark. Which of the following following equations always represent the least square function? So here it will actual minus predicted. In the predicted minus mean, we never use the mean value. Again, we never use the mean value. We use the predicted values and the actual values. Right. So this is how you will find the error. Which of the following option is correct about the gradient descent? It's based on convex function. It is correct. But remember, gradient descent can also be used for convex function as well. But what happens in the case of convex function? It need not to converge to the local minima of global minima or local minima. But in the case of convex function, if you are setting your learning rate to be not very high, not very low, then at some point of time it will converge to the global minima or local minima. But in the case of concave function, it need not to be converged. That's why we don't use the gradient descent in the if the surface is convex surface or function is convex function. Right. So mostly we use gradient descent only for convex function. It weights its parameters iteratively to minimize a function, minimize a given function to its local minimum. Yes, gradient descent is always try to converge to the local minimum or global minimum.
Both A and B.
Yes, sorry, both can be correct. Which of the following is correct about the least square classification? Least square classification is used for estimating parameter of discriminant functions. Yeah, parameter of discriminant functions are nothing but the weights, right? From the given training data set. Yes, this is correct. Least square classification adapts the linear regression model for classification. Yes, it's actually motivated by the linear regression model itself. It uses mean square logarithmic error as a loss function. Not it uses the sum of squared error as the loss function. This option is incorrect. It uses normalization method and gradient descent method for estimating weight vector. Yes, we can use both for optimizing our weight vectors. We can tackle issues of overfitting using this or lasso regularization. Yes, first option is correct. The correct chronological order for implementation of this square classification is, so first comes the training data set, right? Again, model loss function optimization and evaluation matrix. So the option 3 is correct. The correct order of data pre-processing. So remember, always we have to generate first data set. If you look at the options, so one of the part is generating data set, right? So that's gonna be first. So first and answer should be from first and fourth option. Second and third will be cancel out. So the next step is you have to performing polynomial transformation, and here we are dividing data set and then performing the label transformation. So and then we are performing the polynomial transformation. So both should be training and test data set should be transformed to the same feature space, right? Input space. So the second step should be the perform polynomial transformation and then divide the data set. The fourth option should be correct here. Okay, so this code we have already seen for encoding and decoding a label vector, right? So if we are creating a object from the class label transformer, and we are encoding this vector. So what will be the encoded vector here? So first example belongs to class 1, and there are only two classes. So there are only two classes. So first example belongs to 0, 1. So this 0, 1, this will be 1, 0. So this will be 1, 0. This will be 0, 1, and this will be 1, 0. So first option is correct. Right? Again, what we are doing here, we are encoding this and printing this. So we are encoding this. Now here it is gonna be 3 classes here. So 4 cross 3 matrix should be there. So first belongs to 0. So it will first belongs to class 1. So it's gonna be 1, 0, 1, 0. So 0, 1, 0. Yeah, obviously first option gonna be correct. All other options are incorrect, right? Yeah. So let's go to the activity 4.5. What is the output of the following code? np.where Okay, so it will check where these two are correct. These two are true. So
True positive.
Yes.
Number of true positives.
Yeah, so where the actual level is 1 and the predicted level is 1. So it is actually true positive, number of true positives. Perceptron is a classification algorithm. Okay, which of the following is are correct regarding training perceptron on linearly separable data? Examples. So linearly separable example lead to 0 training loss. This is correct. And linearly separable example lead to non-zero. This is correct. Linearly separable data, the optimization procedure eventually converges. Yes, this is correct. And on non-linear separable data, the optimization procedure never converges. Yeah. So if the data set is not linearly separable, then it will never converge. Right? It will keep on oscillating or need not to converge. Okay. So perceptron are motivated from neurons. What are neurons? What is neuron?
Brain cells.
Yeah, brain cells. So you can neurons are the basic unit for neuron system. Neuron system are nothing but the brain system you can think of, right? So there are lots of trillions of billions of neurons are connected in our brain system. So our information passes through neurons, one neuron to next neuron and goes to the brain. So the same idea we are trying to mimic. So actually you will learn in the neural networking. So there we are trying to mimic our brain system, right? There we were here we will try to make such connections. Obviously not we can make trillions of billions of such connections, but up to some extent we are trying to mimic our brain system in the neural networking and deep learning kind of thing. So all the idea is behind those is just mimic our brain system. So those units are called neurons, and in our case it is perceptron. So what happens here, it takes the input and gives the output, right? The same happens in our neuron system. It takes the inputs from the environment and just passes its output to the next neuron. The same kind of structure is we are developing. Okay, so the perceptrons are the basic unit in the case of artificial neural networking.
So this question 2, this non-linearly separable data, the optimization procedure never converges.
Yeah, never converges. Yeah, this is correct.
It is correct or is it wrong?
On non-linearly separable optimization procedure never converges. It never converges for non-linearly separable data set.
Okay, but okay, right.
Is it given incorrect?
It's given incorrect. That's why I'm confused, because I marked it as correct.
Okay. No, I think for non-linearly separable data set, the perceptron will never converge. It will never converge.
Right.
So both options will be correct.
Right. Thank you.
Which
Or
of the
does
following-
non-linearly mean
the data is not
supposed to-
separable.
Okay.
Data is not separable. Not separable using some linear function, linear main hyperplane.
Yeah.
Which of the following activation functions are commonly used in modeling of perceptrons? So this is RELE function. RELE actually nothing but the maximum. If the input is greater than 0, then it is +1, and if the input is less than 0, then it is 0. So the same is maximum of x and 0. So leaky RELE, I'm not sure about. I have to check it. Sigmoid and all these other functions are used in the case of logistic regression and all. Okay, so in the case of perceptron, mostly RELE function is used. So softmax is nothing but for the two classes it is sigmoid, and the same idea is goes for multi-class classification problem. The softmax mechanism comes into the picture. And hyperbolic tangent activation function. Hyperbolic tangent. There's no such model where we preferably use this activation function, but in some of the data set we can use this as well. Rather than sigmoid or softmax activation function, this function can also be used depending upon the data set, behavior of the data set. So this all will come in the week 5. Which of the following are the components, 5 components of the model? So training data set, then model, then the loss function, then the optimization procedure, and the evaluation metrics. So second option is correct here.
Sir, that is testing data. So if you go up, it's not training.
Sorry.
So the last one is correct. Yeah.
Last one is correct. Training data set, model, loss function, optimization, and evaluation. Yes. So total loss can be controlled by changing the weight factors. Yes.
Yes, true.
So what will gonna be correct here? It is just we just add W transpose in the direction of that X size, right? If it is correctly classified, then it will be don't update those weights. If it is incorrectly classified, we just add that Xi in that direction. So adding means that your weight vector gives the orientation, right? So if you are adding those Xi, so you are moving your plane into that direction, right? And if it negative point, then you are going away from that direction, right? So that is the main concept behind perceptron. Which of the following statements are correct? For correctly classified example, the error is 0. So this option is incorrect. The incorrectly classified example, the error is minus of this linear combination and yi. So this option is correct. The error is a piecewise linear function. Error is a piecewise linear function. It is 0 in the correctly classified. Yes. So
it's correct.
Yeah, it's correct because it's a linear function, but piecewise because if the correct in the two regions, in the correctly classified region and misclassified region. In correctly classified region, it is 0, and it's misclassified region. It is a linear function of W's weights. Remember the curve. First it is 0 and then goes up. I mean, first it decreases down and then goes 0, right? So that's why it is piecewise linear function. Perceptron takes in input possibly more than one, with each input multiplied by some factor called feature vector. So actually perceptron take a linear combination and followed by a non-linear activation function. So this option is incorrect. Here it is just a linear combination. We have to use activation function on that as well. Okay, so this option is also correct in the question number 2. 4.7. So what we are printing here, A is given to be level just a vector 0.18, 0 minus 0.18 minus 0.14, and we are printing a and M, or say and just an array where we are printing 1 if it is A is greater than 0, otherwise -1. So it is 1 minus 1 minus 1. So 1 minus 1 minus 1. That's 1 minus 1 minus 1. Second option, 1 minus 1 minus 1. In the video for non-linearly separable data, what is the loss function? Greater than 0, right? If it is non-linearly separable, then it is always greater than 0. It means that it will never converge to the optimal solution. Let's come to the practice assignment. Identify the correct statement. Classification of emails as spammed or not spammed is an example of binary classification. Yes. Because only two levels are present, yes or no, spammed or not spammed. Classification of different types of cars like sedan, SUV, Ford is an example of multi-class classification problem. Yes, because it cannot be multi-level. A single example cannot have two levels associated with it, right? A car can be either sedan or SUV, not both at the same time. So classification of genre of a movie, where a movie can have more than one genre, is an example of multi-class classification problem. This is an example of multi-level classification problem, right? Because a movie can have more than one genre. It can be, whatever genre, more than one genre it has. So it is a problem of multi-class classification problem. Sorry, multi-level classification problem.
Sir, when it will be multi-class classification?
It will be multi-class if each and every movie has only one genre.
Okay.
Okay, so you have feature matrix, you have level vector by. Now you have to find the total loss, and you have weight vectors as well. So we are not going to do any computation here. Just look at the feature matrix, level vectors, and the weight vectors. So weight vectors, by using weight vectors, you can define your plane, separating plane, right? Now look at the examples here. The first three examples belong to the third quadrant, right? Just imagine the two-dimensional space. All the first three examples belongs to the third quadrant, and all the last three examples belongs to the very first quadrant, right? Now look at the separating space, separating line. Weight vectors. So weight vector is given as 0.951. Okay. So one thing is that it is passing through origin, right?
Yes, sir.
So why can't we just, so these are negative, this is a negative number. The first row has negative, 2 negative. So I have to multiply X by W, and my weight vectors are both positive. The first one will be negative. So if it's negative, then it'll be 0.
Yeah, that's what I'm saying. You just need not to do any calculation.
So
just
the second one is also negative into
this is
two
negative,
positive.
this is negative, this is positive, this is positive, this is positive, right?
Yeah,
this
so it'll be 0, 0. Yeah.
Yeah, 0, 0, 0, 1, 1, 1. This is gonna be a prediction. So there's gonna be 0 loss.
0 loss, right?
Clear? So you've been given the true levels, you've been given the predicted levels, right? Now you have to find total number of true positives. So what is true positive? Which are predicted positive and actually they are positive. So these are predicted positive. Third example and the fifth example are predicted positive and actually they are positive, right? So how many are those? 2 are those. 2 are the true positive. What are the total number of false negative? False negative means that they are predicted to be negative, but they are incorrectly predicted. That is, they are positive. So they are how many are predicted negative? This one, this one, this one, this one, this one. So which one is predicted incorrectly? This example, right? All
Right.
are truly positive negative. So only one example there which are predicted negative and actually it was positive. So one example which are false negative. So total number of false positive which are predicted positive and actually they are negative. So there's such no example of such category. Next is true negative. That is predicted negative and actually they are negative. So these are 1, 2, 3, 4. 4 examples are there which are false negative. Sorry, true negative. The decision boundary between two classes is represented with a hyperplane by equal to W naught plus W transpose X. Then on the decision surface, yes, on the decision surface, the Y value is gonna be 0. All other are incorrect options. Considering multi-class classification problem with the 4 classes, this one, red, blue, green, and yellow. So number of 1 versus 1. So how many classifier will be there?
6.
4 classes you have 1 versus 1. Then you have to find possible number of pairs. So 4C2. 4C2 is 6. What will be the output of following code? So sklearn.dataset, importing max circles, mix circles. And we are doing the polynomial transformation on X. So what will be the shape of X? With degree 3. So do one thing, you just import this, you just import this make circles and try to find the shape of X. Okay. From that shape of X, you just make the transformation. Okay, let's do it here.
So, but without the collab, how we can solve this?
Yeah, you have to use collab there.
Sir, in the quiz, will there be any kind of this kind of question?
No. If there are such questions which need collab or some kind of programming, then they won't be in the quizzes.
Okay, sir. Okay.
So, can we say that if it is a circle, then it will be just to, it will be x square plus y square.
Yeah. So
with that, can we solve it?
Yeah. For that, now you have to make the polynomial transformation. It means you have 2 features. Now you are you using degree 3 polynomial transformation. So how many features? How many features there will be there? 1 x1.
One will
x2.
be the dummy one.
1 x1 x2.
Then
x1 square.
x1 square, x2 square.
x2 square, x1 x2.
Yeah. Then x3 square, x1 cube and x2 cube.
Yeah.
Then
cube also.
x1 square, x2 and x1 x2 square. So there will be 10.
10, right?
Sir, is there any formula to calculate this?
You have to find the total number of possible iterations, or not iterations, that permutations, combinations.
By writing each and every possible value.
No, for more than 3 degree, and definitely not. There is such formula that you can find all the possible. But for degree 3, degree 2, you can find it easily.
Otherwise, we'll have to use combination with replacement formula for each of the degrees.
Yeah, that can be done, right? That can be done. You have to make use of knowledge of permutation and combination. How many such combinations you can make, right?
Yeah.
To solve the optimization problem, we generally calculate the derivative. We calculate the derivative ZW with respect to what? With respect to weights, right? Okay, so this is all done. If you have any doubts in week 4 assignments, you can ask, or still not if you haven't done it yet, you can post it on Discourse.
So week 4, the programming are a little tough. It's programming of question 2 and 3.
Graded assignment or practice assignment?
The graded, very tough, sir.
Okay, I'm not opening it here now because I'm not sure whether it is.
Yeah, that's okay, sir.
Okay, so.
Sir, any tips for us if we are not very good at programming?
I'm also not very good at programming. I'm just keep on practicing. That's the only thing about programming.
Sir, in week 3, the programming assignment, the graded programming assignment 1 was quite a long code. And considering that in the exam, we'll be doing it in the portal. The portal gives up some vague errors and doesn't show us on which line the error is there. So
okay, did you check the sample solution there?
Yeah, I checked the samples. No, sir. Actually, the expected output is not given properly this time. It gives a single number digit 1. So we actually don't know what is the output required.
Okay, so which question is this?
This is graded of week 3, sir, the first one. It is quite a long code which I had to write, and then I had to go back to Colab, and there I could identify which line the problem is existing, and then like debug that line of code and all. But if the same thing has to be done in the portal, it's very difficult to do it actually, because it doesn't show us on which line the error is there.
Yeah, you're correct. There's mistake in the portals.
Yeah, so in OP, if we face such problems, it would be very difficult, sir, to actually debug our code.
Okay.
So that's the feedback that I had after having gone through that graded assignment of week 3.
The only thing I can do right now is that I can concern this problem, I can pass this feedback to my team, and we'll consult on that.
Yeah, sure.
Your point is valid. Your point is very good.
Yeah, and sir, instead of giving the expected output as 1, is it possible to give us what exactly? Because sometimes the questions are quite ambiguous, as in we don't kind of understand what is actually required of us to do in the code. So
that can be done. That can be done. That we can take care of.
Okay,
and in the OPA, we will try not to give output as 1. We can even have output as text or something else.
Okay, sir. Fine, sir.
But I have some different opinion, because 1 comes only when our code is correct.
Yeah.
And if our code is
wrong, that is done internally. Don't worry about those things. If it is 1 or -1 something, it is done internally just to make sure your output and actual outputs are correct. We do just equivalence kind of thing.
No, sir, that's why I'm saying means when our code is correct, it shows 1. When our code is wrong, it shows the actual what should be the answer and what is our answer.
Yes.
No, Yogendra, if you see the portal, there is one expected output and there is an actual output. So in the expected output, always it is showing 1.
Yeah. Even
actually, I was solving.
Okay. That happened in. If it is showing incorrect, then it expected output shows correct output, but your output shows 1, is it?
No, sir. It's not about my output. Actually, gives up some error. So suppose if I am coding something and there is an error in one particular line.
Okay. So you want expected output to be the correct output.
Correct output. Actually, based on the test, because anyways in the OP, the test cases, the public test cases are not given marks. It's only the private test cases which are given marks. So if you show us the output, the ambiguity would come down.
Yeah. That also can be done. That can also be done. Okay. We'll check with the team if we can allow this on the exams or not.
Okay, sir. Yeah, that would be really helpful if we can do that.
Yeah, that will convey to the team.
Fine, sir. Thank you, sir.
Sir, and in week 3 graded assignment 3, I shouldn't be complaining about it, but irrespective of what I return, even if I'm returning a normal loss, it's asking for mean absolute error. But even if I return any loss, it is still passing all the test cases. So I don't know if I should complain about it. But
so what do you actually pass there?
No, it's asking for mean absolute error. But even if I calculate the normal, the usual loss that we calculate, no?
Okay.
Even then it is passing all the test cases.
Okay.
So I don't know if there's an issue with that question
Week
itself.
3, question 3.
Yeah, graded question 3, week 3.
Okay, check on.
Yeah.
Sir, I have a question. Is there a reason why the collab notebook for the
not shared, is it?
Hello?
Collab is not shared, right?
Yes. Why is there a reason why it is actually not shared?
Collab is not shared. Just the team. We want you to do from the scratch. You write your code yourself. Do practice. Otherwise, if we will provide you the collab file, what will happen? You will simply run your collab file. You will not write your code by yourself. That's we don't want you to do.
Sir, is it possible
No, sir,
to make at least a PDF version of it?
No, sir, but
so that we cannot
the
copy.
questions, the questions that are asked are not direct enough, and you are anyway sharing the entire file in the video that you are going over.
Yeah.
I don't understand the reason.
So there, what you have to
process
do,
behind
you have
not
to
sharing.
you cannot copy from the lectures, right?
No, that
You
is
have to
fine.
write by yourself. You have to write by yourself.
At least make a screenshot and you can share it in supplementary, please.
Sir, but if you see the
yes, sir, because
if you see
notes
the
is also
if you
very
see the
important.
functions or the methods, it is actually a direct call to the NumPy package that we have. There is no a logic or a data structure involved inside that one.
But
I don't understand the reason behind it. So it would be really
so
helpful.
That is very valid point. But remember, if you want to very good in the programming, there's only one way to do that. Just keep on practicing. You have to, even if you know the concept, if you are not writing down, you are not getting errors, you are not correcting them, you are not going to learn anything in the program. Right?
No, I completely agree. Sir, I completely agree to your point, but by not by way of not sharing the collab file, it is actually detrimental. It is not helping us. That is my opinion, I would say, please.
Okay, so the same,
it is actually not helping us.
Yeah. So same points was taken from the previous term as well, and the sir has we took the point to the sir, and sir denied that we are not going to share the collab files at least for this term. If we are making some other changes, some maybe in the changes in the exam type or then that we can share. Otherwise,
no. Then our question is even more valid, sir. Now that you have told this, why don't you consider? Because if this is a question that has been popping up right from the last term, then it is something that you I would request you to really consider it, sir. Please.
Yeah.
Because
again,
it is a one-off question.
Again, I can take this question to the team, but I know the answers, and I'm telling the same thing.
No, I would rather take it as a typical way of reacting to the questions that is posed, but I would request you to react it in a better way so that it is helpful to the students.
Really, it will be very
That's the
helpful.
ultimate truth that collab files are not going to be shared.
No, we have posed this question in Discord, sir, but we are not getting answers. That's the reason why I thought I will pose it here.
Okay, so the answer is we are not going to share the collab. Actually, I'm also not in the favor of not sharing this, but it's the majority of our team wants not to share, so we are not sharing.
So, Mr. Even sir, there is no problem in not sharing in this collab file. But sir, what happens? Actually, the lectures are of 20 minutes, 15 minutes like that, and means all the functions are interrelated. So if in one video on the other function also, so we are not able to when we type the code, it shows the error. Am I able to convey my point?
I understand it, but I cannot do anything about this. Is what I'm saying.
No, sir. If you can share the codes in the one PDF file so that we cannot directly copy. I am not.
I will again put this point.
I want to.
I will again put this.
Yes, I want to do the
team for sure. Okay, let's see what happens.
So one option could be that I don't know if you would want us to learn all the matplot aspects as well as part of this course, or if you could share it's like, you know, if you give us the collab file but with all the core logic like your loss function, model, etc. can be blanked out, which we could look at the video and probably try it out ourselves, whereas all the other graphing, because practically for us to type out the entire code for a 20-minute video takes about 3 hours, 2 hours.
Yes, sir. Yes,
So
sir.
I'm
Yes,
so
sir.
for
That
so the course initially, which says you need 15 hours to spend in a week, we are actually typing out more than 15 hours or 20-30 hours of time typing out the code. Or if there is a smarter way to learn, I think I'd like to hear. But right now, if I just look at the video and type out everything, it takes me quite a number of hours.
And that's only for copying, actually. It's not
Yeah,
actually.
exactly.
Yeah,
and we won't even remember it.
Yeah.
Yeah, and if you think we are, and that's the way for us to learn, then that is not helping us.
Yeah,
Exactly.
absolutely, absolutely. And
So I
that's
think
why
the
in
things like
PDS Echo, we are
matplot
allowed to do
library,
that.
I mean, wherever, which we think, if whatever you think is not core to the understanding of MLT, which we can probably learn later, maybe matplot library, SSC, Born, etc. If you could give it like a template of all the collab cells, and then maybe blank out your loss function, etc., which we could probably look at the library, look at the video and type, which will probably help us practice. I mean, that's an alternative to not sharing the entire collab file.
So as Mr. Yogendra mentioned, that it becomes very difficult as the one function is dependent on the other, and if the error comes in one particular code, the whole code gets stuck, and from that point, the whole code suffers. The overall learning suffers. So there should be a solution for this.
Yeah, I understand that, but the only thing for now I can do is that I can put all these points, all these alternatives to the team, and we can discuss on that.
At least screenshots, sir, because if you have to wait for a live session to see the code, and if you're stuck up with some line, it's very like time consuming.
It's hard,
Screenshots can be shared. I posted one code error in the morning, and I didn't get any response from anyone. So I'm just stuck at that particular point. I wasn't able to do the later section of the week. That's on because of that. So that's why.
Yes, sir. I am stuck in the week 3, from yesterday, and I posted my code in the Discourse, but the query was not resolved. And Mr. When you are stuck and not able to resolve, your whole week is gone. And since we are all not peer learning is not there, means we are not in group, so we cannot ask for help from others.
Yeah, I understand all these points, and all the points are noted, and definitely I will concern this with the team. And again, you have already posted this on the Discord, so it will be better if you can continue on that, so that all others can have look at those.
So I can't say
it's not just me who can change it,
like,
all the team.
I'm not from coding background, so it becomes difficult for me, more difficult for me on that point of time. To debug that particular code, it took me 1.5 hours, and I got nothing. So it's kind of frustrating at that point. That's why they mentioned.
So
inadvertently, you're making us learn matplotlib and visualization also, sir. So at least if nothing is going to be done, you should at least give the students some extra marks for learning something which they are not supposed to learn. Because with so much of plots,
no, you are supposed to learn. That's why we are doing this. You are supposed to learn all this.
Okay, even in techniques, machine learning techniques, we are supposed to learn the visualization. But then some kind of a refresher should have been given on the matplotlib, because nothing was taught and we are just learning by.
Okay, so these libraries like NumPy, Pandas, and Matplotlib, all if you know the basics of Python, you know how to define variables, how to define functions. Then it's just look at the documentation and just find it out. It's just out googling it and find it out. It's not no one can.
So sometimes it's very time consuming.
Functions, right?
It's very time consuming.
Sir, if we have to go by what you are saying, then the logic of not sharing the